Next speaker is Ryan Adamson. Ryan is the group leader for the HPC core operations group at the Oak Ridge Leadership Computing Facility. Ryan?
Yeah, Todd, do you want to answer any of those questions, or you want me to go ahead and jump on in?
So I thought Samir wanted me to answer them in chat, so I'm happy to do
Oh,
that.
okay. I gotcha.
But if you want me to answer them out loud, that's fine. I don't know if that.
No, we're good.
Okay.
I'll go ahead and start going here. All right, let me know when you can see my screen.
Yes, we can.
All right, great. So, so Todd Gamble and I actually have been working really closely over the past 9 months to bring his, team's Spack vision and capabilities to the facilities, right, where we actually have systems that are interesting and kind of help us expand the architectures that E4s will ultimately be running on. And so I never know if it's good to go before Todd or after Todd, because he covers so many things that I want to cover. So this time I wanted to take maybe a step back from the technical specifics of what we've been doing at the computing facilities and talk more about the way in which the facilities approach problems and what their values are, I guess. And so I guess let's jump on into it. So with one hat I wear a group lead position at the Oak Ridge Leadership Computing Facility. With another hat, I have a role in software deployment of facilities under the Exascale Computing Project. And so as part of that, we're taking a lot of the tools and libraries and programming models and runtimes coming out of the software technologies focus area that Mike Haru leads. And we're really the last mile, okay, in terms of not only getting that to the facilities so that users can use it, but also bringing facilities to the software technology teams. We're enabling access so that we can port codes and use accelerators and use new compilers and things like that. But also we're interested in these GitLab CI frameworks to help shorten the development cycle. And so this is pretty new for facilities. We'll talk about this in a little bit. So under me, I've got two main kind of areas. One is software integration. So this team sort of like liaises, I guess, with ST teams and with E4s to bring the software. They're the ones actually building and deploying Spack stacks at the facilities for ECP. And I won't go into all of this here, but it's here if you want to check out the slides later after my talk. The other main area of my effort is CI infrastructure. So this is developing all of the interesting features we need in GitLab CI to support job schedulers, to support multiple nodes, and a single sort of like CI run and stuff like that. And I'm not going to touch on that too much here, but that's a major part of automating the building, testing, and deployment infrastructure that we're trying to build out as part of ECP, and E4s kind of contains all that for us. So in thinking about this talk, I wanted to give some overview of maybe the values that the facilities have versus values that maybe software development teams have. And whenever I think about the issues or maybe the hardness of the problem that Todd alluded to, right, where if it was easy to build and deploy CI processes at these facilities, it would have been done already. If it was easy to get facility resources to automatically build and test and report back problems with merge requests for Spack, we would have already done it already. There are these hard problems that we're trying to solve. And so whenever there's like this intractable problem, I like to think about this in terms of maybe like market forces or the fundamental nature of the people involved, the teams involved, and what their value systems are. So kind of growing up in the OLCF, I was a security engineer for 10 years, and I've seen systems come and go. And when we deploy a system, we, first, before we deploy a system, we issue an RFP. We try to figure out what the science will look like, what the proposals will look like during the lifetime of that system. And we architect the system in order to meet the user's needs, right? The scientific user's needs. In industry, the scientific users are not the users, the benefiters of good code practices, it's the shareholders, right? And so if your software deployment company can build and test and install and deploy versions of your software and features faster than your competition, right? You make more money, you have more value. And so a lot of the CI and building and testing frameworks, et cetera, that are industry best practices are forging the fires of, the ultimate bottom line is how much money you make. And so taking those tools and mapping them back onto the facilities can be a little bit interesting. I think it's important to do that because there are really great things out there, but we have to understand how the facilities operate to make it like a good value proposition. So in terms of system deliveries, the way the facilities work, right? We issue the RFP, we understand the build SAL, we talk with the vendor, and then we finally get hardware, which is here on the left side of the diagram. So time runs to the right. And we have a lot of work to do once we get these early nodes, right? We have to make sure the hardware works. We have to make sure it performs appropriately. We have to make sure that the system integrates with our infrastructure, LDAP and DNS, right? And that meets with our security plan and all of these interesting things that I think some people take for granted. Users, I think, take for granted a lot of the time. And then, of course, we deploy a facility software stack. Typically, we take stable, software packages and we provide them as modules, and then we develop some documentation and support. And then we run our acceptance tests. And assuming that everything checks out, we've done all the work we need to do, then boom, early science or friendly users get access to the system. They check it out. They let us know what happens, if they like it or not, if we need to change anything or tweak anything. And at that point, the facilities typically freeze the bulk of the features that are going to be available for the lifetime of that system. One is because the vendors in their contracts don't want to support much if they don't have to. And two is that the facilities want to maintain a stable software environment for scientists. We don't want to rip out libraries underneath users because and change them because users will run the same code and get a different answer, or something will take longer to run, or something like that, right? And that causes sort of like tickets to come in, work to be done, and it makes for a bad user experience in our view, right, in facilities view. But then over time, scientific users gain more experience and understand the platform better, and they get more productive with it, right? And so what we see here, right, is this natural inclination for a facility to set up something and put it in motion and then just let it run, let it sit. Don't change it, right? It's working, don't change it. But that's kind of opposite of what we're trying to do with E4s and testing, libraries as they come in and come along and get developed on. So I've got these ground level truths that I've been thinking about that we can come back to, but this is what I think is true about facilities. These Department of Energy user facilities, I mean, it's a capital U, capital F. It's a scientific instrument, is what we're deploying in these facilities. In some sense, they are bespoke, and they have to be bespoke. It's a fundamental property that these systems are unique. If we were just buying nodes of AWS, EC2 or something like that, why would we be doing it? There's some, some reason, and we've talked to the scientific users about the use cases that we're deploying this system this way with these accelerators and this network interconnect. And so because of that, it follows, I think, naturally that we're going to have some tuning and wrangling in order to get software that's been developed to run on that system, to be supportable, okay? And I think that's something that we can hook into later and say this step of the process is much easier if we, buy into E4s. The second fundamental truth about facilities is that consensus is hard, okay? The operations staff at and within a facility, and I've never seen a facility that didn't have great, excellent operational staff. They're amazing. They know what they do. They do it well. They're tuned to system delivery timelines. They know how to install software, and that's what they do. They're good at it. But facilities, because of these systems that are different, have different ways of doing this, different customer bases, so they have different ways of doing this. And so getting consensus across facilities is hard. I mean, I even think getting consensus within a facility is hard. I think any team of people, respectable engineers that can form a consensus quickly, probably already had trust, built up among them before the problem statement was delivered even, right? And so just communication has to happen to get this consensus. And I also want to point out that there's this Devops barrier where you have software that's developed. Used to be we'd throw it over the wall of the operations teams and we say, this is really weird. Like, how do we run this software that's got bugs? How do we contribute and fix it? Well, I think that's something we hook into later as well, and say like this ecosystem that we're developing is going to fix this problem. And then the third thing, I don't want to touch on this too much. Todd mentioned that not much of the workloads on HPE resources are containerized, if you will. But I think the reason is that there's a fundamental incompatibility between sort of like the greatest strength that you can think of when you think about containers, which is portability, right? I can shove my application, all my libraries, and I can, test it on my laptop. Cool. Now let's go ship it off to the cloud. Cool, that works. Same architecture. But when you have bespoke systems that are very unique, it loses some of that advantage because you have to put some layers in between or build your image differently or something like that. And so I think that facilities staff have been reluctant to sort of adopt HPC container runtimes because of that reason, and also because of the vendors need to support the runtimes and other things. But we're working on that. I will say that each site that I work with, each facility, does have a pretty strong generic like container orchestration platform. Right, so the OLCF uses OpenShift, which is based on Kubernetes for a lot of our services and user services that we have. So it's not like we're afraid of containers. It's just containers as HPC runtimes, right? HPC container runtimes is a little bit interesting. So then the hard places that we're trying to bring together, right, to the rocks here, is this idea, and everybody here knows this. If you can integrate your build, test, deploy loops, everybody wins. The software is better, errors are detected immediately, faster time to fix happens, you spend less money on these projects, you can do more. Software can be deployed by both users and facility staff, since all of this specialized knowledge is being parameterized in Spack packages or Spack stacks. And essentially, like, this breaks down that operational like DevOps deployment barrier, I feel like, personally. And the second sort of like fundamental truth about the E4s ecosystem is that improving the quality and standardization of scientific software gives us, the facilities, confidence about that software. So, I mean, 6 months ago, right, we had open questions about how will we support E4s packages? How will E4s standardize and provide documentation the same way, or Spack packages the same way, et cetera, right? And we're making a lot of progress there, which gives facilities warm fuzzies, and that's what we need for facilities to adopt a lot of this into their ecosystem. Just the fact that tests have run and have passed on facility systems before, OLCF thinks about deploying something means that there's less work we have to do. That's really cool. And facilities can contribute back. We can write test variants that are of interest to us. We can write our own tests. We can, the OLCF maintains forks of Spack packages that we had to fork to fix a weird compiler problem, right, on a weird, interesting system. So if there's a place or a way that we can merge that back up and talk to the ST teams responsible for that package, then that's great, right? And so all of these things give us warm fuzzies that if a product is inside of E4s, if it's a member package, it will be easy to install and deploy and support, okay? So Todd showed this slide. I think this really gives a good overview of what the promise of this E4s ecosystem means for at least the Department of Energy facilities that I work with and with my OLCF hat on. So I'm not going to spend too much time on this. I think this has been talked through. I will say, though, that this is not just bug reports and patches, but there's also two-way communication, questions that the facility staff can ask. Because the facility staff have these tickets that come in from users. If they say, I'm going to support a piece of software, users will put in tickets, to understand what the problem is. And so it doesn't just need to be a passing of the ticket to this, the development team. It can be a question, or go to the documentation and try it out, and then the facility staff can actually answer a lot of these user problems. So, and that's one of the things that we're actually graded on is as facilities, is how fast do we answer and acknowledge and complete the resolution of these tickets. So having software that is really well supported from a development standpoint means that we feel better that we can meet those metrics that we have to DOE. So I guess like we turned the corner, I would say, in terms of the facilities kind of all understanding what E4s is and feeling more comfortable about it maybe 4 months ago. And I think we had to do several things in order to achieve that. And so I want you all to take this away from this talk, that we really did these 5 things in order to get the buy-in to start the conversation even with the facilities, right? So the first, I really recommend this if you're working with lots of hard places, is to assure each of the facilities that they have the flexibility to implement these things on an a la carte level. Okay, I think there was consternation at the beginning that the facilities would have to deploy every single thing in E4s. No, you don't have. You deploy what makes sense for you, but membership in E4s means you have some of these guarantees, right? And you should feel more comfortable deploying these things. Facilities will deploy products outside of E4s as well. So that remains the same as they normally would have done it anyways if E4s didn't even exist. And so Spack Stacks is the language, I would say, with which we're implementing this thing. So you can add or remove things to a Spack stack based on what you want to install at the facility. Okay. It really was helpful for me talking to leadership in ECP and also my team members to understand the various use cases that we have. And there are really 2, right? So the facilities teams want stable, supportable software because they're going to get tickets. They're going to have to do work based on user issues that are discovered. So they don't want to cause issues for users. But developers need this immediate feedback, right? These scientific systems, resources are there. Users can stand up GitLab runners as themselves and test software if they wanted to. But that just seems wrong. We don't want every user running their own runner, right? But developers need this immediate feedback. So splitting this sort of like build, test, deploy model up into 2 use cases. One that we're operating on with the Spack develop branch, kind of Spack mainline, we're calling it the latest use case, is cool because we can let the E4s teams run with deploying those build pipelines at our facility resources. And the facility teams can take, and I'll show you this in a little bit, tagged versions of Spack commits that the E4s team sort of certifies as a release, right? That there's some guarantees around that and some compiler versions that it was tested with, et cetera, that we can start with. So separating this out meant that we can have a better delineation of roles and responsibilities, right? So facilities teams don't need to be testing all of the latest Spack stuff. And Spack and E4s teams don't need to be making sure that all the facility problems are addressed. So we're sort of putting the right spin on it at the right places. Another thing that I used a lot is this analogy to describe just complex ideas of what E4s is. So Red Hat, right, develops, builds, tests, and provides packages for a Linux distribution, who knew? And facilities buy into the support model, which is in some sense, I think, a very good analogy to what E4s is to a facilities operations person, right? It's giving me these guarantees that, hey, I can go, there's doc, I can go, there are workshops, I can go and there are developers that I can talk to, I can raise bugs. And that's something that I think is really important. And then I think the last is you need to start from a common framework. And for the facilities, everyone was using Spack. So that was really a natural place to start. And that was really because of the hard work that the Spack team has been doing over the last 5 years to really show the value of that product. And so then this slide is called Crucial Conversations, which there is a book called Crucial Conversations, and it's about hanging in there when it gets tough to talk. I think it's actually a really interesting read if anybody's interested in picking that up. So going after Todd, right? This slide is, I think, pretty much useless, but I'm gonna leave it in here because if somebody looks at my talk without looking at Todd's talk, there's a little bit about Spack. I also want to say that these are the individual components of ECP's ST products, and this is kind of what I give the facilities is their a la carte menu. You know, you can pick any of these or none of these. I don't really care, but the choice is yours. So, you know, build your Spack stack accordingly. So I wanted to show a little bit about how this works in practice. Up here in the top left, we have, you know, these are ST products, but these could be any member package of E4s. As they release features and their packages get updated, right, there's a pull request into Spack. And so Todd, right, would like PRs to be tested before merging, which from a facilities perspective, we're working on that. That's a crucial conversation we have to have. But once it's merged into Spack, that means someone's looked at it and has said, this is great. Then we kick off our pipelines, okay? And so we have the two use cases here. So there's this development branch. This is the commit for this example, I don't know. And there's so pipelines run and reports kind of come back, and then if bugs need to be fixed, they're fixed, okay? But facilities can also pick up this particular commit. And if it's tagged with something like E4s Release 1.0.7, that can become the supported version or another supported version of the E4s stack at a facility. So I expect that the facility E4s teams to be talking about what features are coming out soon, and once they're available to create like a real good release that facilities can then pick up and understand what's in it, right? And so maybe there's a manifest or a change log that we also need to start thinking about having for facility consumption. Like, what's new with E4s Release 1.0.7? These features of these libraries were added. I think that would be really cool to have kind of at a higher level than just the distributed package area. But these things become then Spack stacks. Each of these might be a different version, and facilities can handwrite these if they want to. They can take the release, modify it somehow, which is probably going to happen, but they can be made available as modules. So that's really cool. And then users, on the other hand, this is the facility facility and E4s sort of like pipeline case. Another case down here is this user maintained Spack environment that Todd talked about. They of course can pull the latest down and do whatever they want with it, but I think there's also value in pulling what the facility has, right? So like if the facility chooses in this previous slide only a handful of these packages, but a user wants something else, but they want the guarantees of E4s, they can pull the same version, right, that the facility has built and sort of like rebuild it and use the facility's binary caches that the facility might do some tuning on, right, to make run better. So I think this is a really cool, flexible model, a lot of components. So it's really hard to talk about this with folks that haven't really been exposed to this development lifecycle before. And so as an example, kind of like in time, right, time goes to the right, we have the E4s sort of like latest use case up here at the top, and this stable facility interest use case that will be deployed as modules kind of down at the bottom, right? So the feature in HDF5 is developed and, as that new version is emerged into the Spack package, it gets tested, right? Maybe everything's fine. And then a feature Cocos comes in and it gets tested. Maybe something's wrong, so a bug fix is made. This is great, right? We want this to happen. This is a great cycle. So facilities say, I need this version of Cocos. This feature is really cool. So the E4s team maybe cuts a version of E4s, called it 1.0. The facilities run their test suite. Maybe it's reframe, maybe it's bash scripts, I guess, I don't know. Maybe it's just the E4s pipeline. Whatever it is that they want to do down here, they can do. And then if everything checks out, then they provide it their users as modules. And then boom, you've got 1.0, okay? In the meantime, right, development has not stopped. However many commits a day happen, is it 30, 100, something like that, commits a day happen to Spack. It's pretty cool. These things keep going. Facilities say, I need that feature in Adios, but facility test fails. Why is that? We go do some debugging. Maybe it's a problem with Spack itself. That checks out. We pull down that new version, checks out, and now E4s, version 1.1.1 is available. So we have two versions. And then, as you'd expect, this kind of just keeps continuing to the right. And maybe E4s 2.0 comes out, and now we have that version as well. This gives each facility the flexibility to support the versions of E4s they want, but also they can roll and say we support the last 3 versions, and we're going to get rid of the older versions so that, so scientific users just expect that you'll have to be porting your codes. But it's easy because you can use our testing frameworks to make sure that your scientific codes give you the same answers using the latest libraries or whatever you want to put on top of that. So I guess in conclusion, I found it really useful to identify these fundamental truths, right, about the shared and the separate goals of the facilities and developers, right? It's really these truths that are the rocks in the hard places, not the facilities or the developers. It's these conflicting missions, not conflicting, but missions that don't always meet in the middle. But we can make a strong case that we need to join the E4s ecosystem, right, to make everyone's lives easier. And we're making that case. It just happens to be going, I mean, if you think about 4 months, that's pretty fast, really, even moving the progress we've made. And so like Todd mentioned, E4s is being built and tested at the leadership computing facilities and also at NERSC, and it's scalable, right? We can add new facilities, we can add new test systems as we want, and the E4s teams can use that as input, right? And then really, collaboration can only strengthen the scientific software ecosystem. So I think with that, that concludes my presentation.
Thank you, Ryan. We have time for a few quick questions.
All right, great. I don't think I see any questions in the chat.
I already answered them all.
Oh, thanks, Todd.
So
it's good to go after Todd so that Todd can answer all the questions for you. I figured that out.
Well, if there are additional questions, Ryan, please monitor the chat and answer them. We'll
Absolutely.
transition to our next talk.